So the rest of this unit is going to focus on solving triangles that aren't necessarily right triangles. And when we're not dealing with right triangles, those pose their own unique challenges. For one thing, we can't use the Pythagorean theorem when it's not a right triangle. So what I mean by solving a triangle, again, means finding all of the sides and all of the angle values. Once we have all of that information, then that means that we have solved our triangle. Now, in order to solve for an oblique triangle, you need to be presented with 3 pieces of information. Like I said, the rest of this unit, the next, 3 lessons, will break down these cases. Today we're just going to look at case 1 and introduce the law of sines. And then we'll finish up law of sines on the next video. And then the final lesson for this unit will involve the law of cosines, which is dealing with case 3 and 4. But let's go ahead and introduce all the cases we're going to look at. So case 1 is when we have 2 angles and 1 side. So the first example of that is ASA, or angle side angle. What that looks like is I have an angle, the side, and then the second angle. So the side is kind of in between the 2 angles. So this would be angle, side, angle, ASA. The other instance we have here would be side, angle, angle. So side, angle, angle, or SAA for short. Now, when we have case 1, we're going to utilize the law of sines in order to help us solve that triangle. We'll talk about what the law of sines is in a little bit. Case 2, we're going to deal with in the next video. Okay, case 2 is when you know 2 sides and the opposite angle of one of those sides that you're given. So SSA would be side, side, angle, or SSA. Please write it as SSA, right? Don't need to put ASS all over your paper, please. But case 2, we are still going to be dealing with the law of sines. So this is what we're going to do today. So this is part 1. Case 2 will be law of sines part 2, which is what you'll do in the next lesson. And the final 2 cases, case 3 and case 4, deals with the law of cosines. And that will be part 3 of this. Okay? Now, case 3 is when you know 2 sides and the included angle. So SAS, side, angle, side, right? SAS. And then case 4 is when we know all 3 sides. So S, S, S. And again, for 3 and 4, we'll use the law of cosines, but we'll talk about that later on in another video. All right, so again, focusing on case 1. Okay, ASA or SAA. We're going to utilize the law of sines. So what is the law of sines? So the law of sines is this equation right here. Okay, so if you think about a triangle, okay, here's angle A and side A, angle B and side B, angle C, side C. So sine of alpha over A equals sine of B, beta over B, equals sine of gamma over C. Let's pretend that's a uppercase C, whatever. Okay? The important thing to note is that the side and the angle make up the fraction. Okay, so I'm going to do A and A, B and B, C and C. Okay, they always stay together. Now, the way this is going to work is it's always going to give you one completed ratio or one complete fraction, and then we're going to use cross multiplication to kind of find that missing piece for the other part. Okay, so just like we did in the last video, Step one is always going to be to set up your triangle. But again, this time we don't have a right triangle, so we're going to set up an oblique triangle. And it tells me that angle A is 20 degrees. Angle B is 75 degrees. I don't know C. And side C is 4. So I have side, angle, side, angle. So this is ASA. Okay, again, which means that this is case 1. And I'm going to utilize the law of sines to find my missing pieces here. First things first, though, let's go ahead and find our missing angle. That kind of makes things a little bit easier for us. So, A plus B plus angle C all has to add up to 180. So that means that angle C is 85 degrees. So I have 85 degrees, and now I have a completed ratio. I can do sine of C over side C, which is 4. Now, I'm going to write out the whole equation for this problem, just so you can see everything that's going on here. So, sine of A, so sine of 20 degrees, all over side A, which I don't know, equals sine of angle B, which is 75 degrees, over side B, which again I don't know, and then sine of C, which is 85 degrees, all over 4. So there's my completed ratio, and I'm going to use that twice to find A and then to find B, so it's going to be like 2 separate problems. The first problem, I'm going to set this fraction equal to this fraction, and then solve. And then the second part of the problem, I'm going to set these two equal to each other and solve. Okay? So let's go ahead and do that. Sine of 20 degrees over A equals sine of 85 degrees over 4. So again, I'm going to cross multiply. So 4 sine 20 degrees equals A sine 85 degrees. Dividing both sides by sine of 85, I would get A equals 4 sine of 20 degrees all over sine of 85 degrees, which would leave me with A equaling 1.37. Now again, there's no units here, so I don't have to include those. Now, the second part, finding side B, I'm going to do those two fractions. So sine of 75 degrees over B equals sine of 85 degrees over 4. Again, cross multiply. So 4 sine of 75 degrees equals B sine 85. Divide the sine of 85 degrees over. So B would equal 4 sine 75 degrees all over sine of 85 degrees. Punch that into your calculator. Again, make sure you're in degree mode. Otherwise, your answers will come out a lot different than mine. But we get B equaling 3.89. And that's it. Alright, so if you want to try B on your own first, before I do it, go ahead and pause the video and give it a shot. I believe that this is an AAS triangle, but you do the same process, okay? So go ahead and try that on your own first. Alright, so first things first, let's set up our triangle. So A is 50 degrees, B is 20, and then side A is 3. I don't know what C is. So this is angle, angle, side, or AAS. So again, case 1, law of sines. So let's first find angle C. Okay, so 50 plus 20 plus angle C equals 180. So that means that angle C has to equal 110 degrees. Now, I'm going to go ahead and split this into the two equations as my first step, instead of writing out, this equals this, and then breaking it apart. I'm going to start by finding B, so side B. I'm going to find this first. So this is the ratio I'm given, so sine of 50 over 3, and I'm going to use that to find side B. So sine of 50 degrees all over 3 equals sine of 20 degrees all over B. I think it's easier to just split it up on your first step. That way you don't get too confused looking at too many things at once. Again, cross multiply. So B sine of 50 degrees equals 3 sine of 20 degrees. Go ahead and divide the sine of 50 degrees over. So 3 sine 20 degrees all over sine 50. So side B is, punching that into your calculator, you should have gotten 1.34. Alright, now finding side C. So again, I'm going to use sine of 50 over 3 equals sine of 110 over C. Cross multiply. And divide. So C equals 3 sine of 110 divided by sine of 50. Punching all that into your calculator, you should get C equaling 3.68. Alright, so that is case 1 using the law of sines. Now, real quick, we're going to do 2 more problems, but they are word problems, unfortunately. But let's look at utilizing the law of sines to help us solve a word problem. Alright, so this one gives us the picture already made, which is kind of nice. So, consult the diagram. To find the length of the span of a proposed ski lift from A to B, so what we're trying to find is this length right here, A to B. Okay. The surveyor measures the angle DAB to be 25 degrees. So DAB is right here, and that is 25 degrees. Then he walks off a distance of 1,000 feet to C and measures the angle ACB to be 15 degrees. What is the distance from A to B, and how high is the mountain? So this is a 2-part question. This will be A, this will be B. Alright? So first things first, let's find the distance from A to B. Alright? So we'll go ahead and say that that side length is length x. We don't know what that is yet. We have to solve for it. Now, in order to do this, I want to utilize the law of sines. So I want to find my angles A and B. Alright? So if I know that DAB is 25 degrees, then if I add DAB with CAB, that would give me a total of 180 degrees. So if I subtracted that 25 from the 180 total, that would leave me with 155 degrees. So that would be this angle right here. That's 155. Now I can figure out my final angle in that triangle. This right here would be 155 plus 15, which would leave me with 10 degrees. Okay, it's messy. Okay, this angle is 10 degrees. There we go. Alright, so for the first part here, that length x, a to b, corresponds with this angle 15 degrees, right? So the sine of 15 degrees over x equals, and we have one completed ratio now, right? If we look at angle measure B, which was 10, and its opposite length, 1000, I can set up that fraction. So sine of 10 degrees over 1000. Cross multiply. 1000 sine 15 degrees equals x sine of 10 degrees. Do your division. So x would equal 1000 sine 15 degrees divided by sine of 10 degrees. Plugging all that into your calculator, you should get approximately 1490.48, and this does have units. It is feet. Okay, so that is the distance from A to B, or the length of that ski lift. Now, the final part of this problem, part B, is asking how high the mountain is. So it's asking us to find this distance from B to D, basically. So if we think about just that right triangle, so let's redraw it to kind of simplify things a little bit for us. So we have D, B, and A. We're trying to find that length. And we know what our hypotenuse is now. That's what we found in A. That was 1490.48 feet. And we know that this angle is 25 degrees. So, think back to last unit, right? We have our right triangle. I want to use my angle measure that I know. And I have a hypotenuse, so I want to think sine or cosine. And I want to find the opposite side. So that means I want to deal with sine. So sine of 25 degrees equals opposite over hypotenuse. Multiply, right? So y would equal 1490.48 sine of 25 degrees. So the height of the mountains would be 629.9 feet. Alright? Alright, last problem. Now this problem's kind of tricky because it deals with coordinates and thinking about north, south, east, and west, which can get a little confusing. So, let's go ahead and get started. Two fire lookout stations are 10 miles apart, with station B directly east of station A. So think about your compass, right? North, south, east, west. So B is directly east of A. So if I think about drawing a picture here, here would be A. Directly east, so to the right, would be station B. And that is 10 miles apart. Now, both stations spot a fire. So we have a fire up here. Okay, so there's the fire. The bearing of the fire from station B is north 56 degrees west. So that means if I look north, I want to look 56 degrees to the west, so left. And that's what makes this problem tough. So I would have this, okay? And the bearing from fire station A is north and then 25 degrees east or to the right. So if I look north, I want to look 25 degrees to the east or to the right. So that would give me this triangle, okay? So I have those outer angle measurements, but that doesn't really help me with my inner triangle measurements. So I need to kind of figure those out. So if this is 25 degrees, the total would be 90, right? So that means that inside, this would have to be 65 degrees. Same process, if I think about this as a right angle and 56 degrees on the outside, that would leave me with 34 on the inside. Adding all those up and subtracting from 180, that means that up here would be 81 degrees. Right? So it's asking me to find how far the fire is from each lookout station. Now this is where things are going to get a little bit confusing. So if we say that this is angle A, right, station A, its side is going to be here, but that's the distance from station B to the fire. Likewise, if we look at angle B here, its side would be here, but that B is going to represent the length from station A to the fire. So it's a little bit confusing to think about it like that. So you want to be careful when you're doing this problem to make sure you're not mixing up what we're solving for. So let's start with station A. Okay, station A is B distance away from the fire. So the ratio I do know is the 81 degrees with a length of 10. So let's start there. So sine 81 degrees over 10 equals, now again, the side length that is denoted by B is the distance from station A to the fire. So that means I want to use the 34 degrees in the B. So sine 34 degrees over B. It's kind of backwards when you think about it like that, but that's kind of what happens here. Cross multiplying, I would have B sine of 81 degrees, 10 sine of 34 degrees. Dividing, we get B equals 5.66 miles from station A to the fire. Alright, now doing the same thing for station B. So again, we're going to start with what we know. We know sine of 81 goes with 10. So sine of 81 degrees over 10. Now, the side denoted with A represents the distance from station B to the fire. So that means I want to use the 65 degrees in the A. So sine of 65 degrees all over A. Cross multiply. Divide, and we get A equals 9.16 miles from station B to the fire. Alright, and that's it. That is the law of sines for case 1.